لكن خلينا نسويها مع بعض. اوكي على السريع. I'm gonna create a new notebook. Save as exercise 1 underscore 1 class. Okay. This is my exercise. I will start registering this. Okay, I'm registering already. So import numpy as np. The matrix A. The matrix A is this matrix. So you have two options. You can define your matrix from the beginning as a list, as a list of lists. Okay. So it is made of 3 sublists. Okay. It's seen like this. It means you have 3 blocks, and in each block you have 3 series of 3 lists. The first one is 257 314. Okay, so 257 314 and 251 and 251. So what is different from and if any time you will work with MATLAB, in MATLAB programming, it's optional. You can put the comma, you can forget not put it. If you want to create a matrix, the next line, you need to make a semicolon. A semicolon to pass to the second line. In Python, if you create a list, when you do it like this, it means that you have A have 0, 1, 2, and in the 0, 1, 2 you have here in this case 0, 1, 2. Certainly, if I would like to convert, so imagine, for example, I would like to take this, but instead I would define B just for our discussion. Imagine B, instead of the second this element, I will write, for example, hello. Okay. So now, if I would like to convert, I can write, for example, I can overwrite A and say A is equal to np dot array of A. Or you can define A1, which is np dot array of A. In that case, A1 will be, we can do it like this. Huh? We can do it like this, just for the discussion. So if you run it, or maybe I can write in a plot the type of A, okay, and the type of A1, you will see that, print, I'm sorry. Okay, so as you see, A is an array, A1 is a numpy ND array. If you try, for example, to convert B to an NP array, it will not work. Why? Because it's not homogeneous, it's not numerical. So if you do like this, for example, B1 is equal to NP array of A, you will have an error automatically. And this error would be like this. So you have for A the prior print for A1, and for B he would say that setting an array element with a sequence, the requested array has an inhomogeneous shape. Cases when you use NumPy, the information is even in the name of the library. It's a numerical library. All the linear algebra, you know, how to diagonalize, how to do Chomsky factorization, how to calculate the determinant, the the eigenvalue, the eigenfactors of a matrix, etc. How to solve a linear system. This is the objective. And you will use it in many other things. You will use it to create a log series of data if you want to plot or do something similar. Okay, so in our exercise, maybe I can, I will delete this. Okay, so just it is only for our discussion. I will overwrite. I will write like this. So now I have A, an NP array. If you last time we said that we would not replace A02 because this is the biggest value. And if you replace it by 0, you will have the maximum equal to 5, and the maximum appears in two places. That's why I didn't want to, maybe I can replace A02. And another thing, in A is a list at the initially, but you convert it to an NP array. You have two ways to access to the values. You can do the same way as you do in lists. Yani for example, if I would like to access to the value 7, this value 7 is in the block 0 and in the position 2. So 0, 1, 2. So I'm gonna, if you were working with lists, you will do it like this: A0, 2, and you can allocate any value. And in the exercise, it's given equal to 0, but I can put 9 or 19. If I put 19, for example, I will have my result. Maybe I can print A. So as you see, A is a type array. If you print A now, the result would be like this. So you replace it 7 by 9. But in the practice, it is better to do it like this. Look, you will do, it's mandatory to do it in this way, but if you are working with an NumPy list, it is better to write it as you are working with matrices. It is like this: A 0, comma 2 equal to 19. In this case, or equal to 17. So if you run it now, it is equal to 17, and it is more appropriate to write in this syntax. There's a lot of syntaxes, and even in printing, لما في البرنت لما نحط variable نحط format, there are 3 ways to do it. But I prefer working with format. And when you are working with NumPy array, it is better to do it like this. Okay, I will tell you why. When we will continue, I will explain why. So last time we worked with this. I'm gonna do it. So execute the max, mean, etc. I'm gonna do it rapidly. Just a second. So create a new cell. This cell will be a markdown. Okay. So font. Please, if you have any question, just ask me. Okay. Okay. So this is my question now. Okay, just to finish with this today. So font, okay, color blue. Okay, no, it's a small. Size equal to 4. Okay. Now this is. I would like to do this. So let's do it. I will define my first maximum, max 1. So here I will print before, just to be to become organized. Print. I will put something, and I will write maximum calculation. Okay, and I will put something here also, and in maybe I will use the same variable 0, and here 0, for example. And in format, I can put the symbol plus. So when you print it, it appears like this. Just to be something a little bit organized. I would like to make it more organized. I can do this 20 times. Let's try it. Because it's a string. So just to gain time. So I put it to the left and to the right. I can put 30 here. Maybe it is better. So like this, it will become more easy to read. So this is my, so here I will say max1 and I will add an enter just to make this anti/n, sorry. So max1 is np dot max of the matrix A. If you do it like this, you do the max of the max. So if you print it, print, okay, I'm gonna write it max1 equal to dot format max1. Okay, so if you're where is my np dot max of sorry, here I should add my brackets, so it's equal to 17 because here we replaced, I changed it a little bit, so I replaced this value by 17, so the maximum of the lines and the columns is equal to 17. Okay, the second way is to play by dimension. So max2, I'm gonna do it like this, and max3. Max2 would be the max of A along the lines. So by column, you are finding the maximum by column. So axis 0. In that case, maxis 2 will be, I can comment this for the moment, just to show you the result and come back. Okay, so if you run this, you have 3, 5, 17, because the maximum here in this column is 3, here 5, here 17. The third maximum we will use it is here I said max2, here x max3 and max3, but instead of, so this is max3 axis equal to 1, so in the other dimension. So in this case, you will have 17, 4, and 5. Why? Because the maximum of 257 or 2517 is 17, and the maximum between 3, 1, and 4 is 4, and the maximum between 2, 5, and 1 is 5. So this is concerning the maximum. Now let's pass to the next point. It's the same logic. I'm gonna create a new one here, and then I will call it minimum. Okay, so here min, minimum, and the function is min, and min. So here I will call it minimum 1, minimum 2, and minimum 3. Well, normally everything is okay. So if you run this, maybe I have some هنا min 1, here min 1, and min 1, min 2, min 3. Okay, I run it again. Now these are my minimums. Why? Because the matrix A, just remember the print A. Okay, because this is my matrix. Okay, so if you put the minimum here is 2, here the minimum is 1, here the minimum is 1. So if you look now like this, 2, 1, and 1. You should not be a little bit because you did find the same result, but it's different. If I change the value, the result will differ. لو غيرت الواحد هذا بثلاثة، النتائج الاثنين حيتغيروا، مو نفسهم. Same thing for the other calculations. if you want to calculate the sum, you do the same, the sum by line, the sum by column. Okay, so if I would like to calculate the sum, it's the same logic. Okay, I'm gonna calculate here the sum. So in this case, sum 1, it's in here NP sum of A. هنا I'm gonna write sum 1, which is the sum of all the elements. Sum 2, you can do the summation على by column. So this is the sum 2. Sum 3 is على axis 1, يعني by line. So I'm gonna write here sum 3, the variable, equal to sum 3, and here sum 3, sum 2, and if you calculate the sum, these are your results. No, here this sum. Okay, so I have 40. The sum of all these elements is equal to 40. Just you can verify this. Now, if you sum 2 plus 3 plus 4, you have 7. Here you have 11, and here you have 22. Now, if you do the sum on axis 1, 7 plus 17 is equal to 24. Here you have 8, and here you have 8. Okay, so this is concerning the sum. You can do the same for the mean, which is the average. We have already this. I would like just to save time. I would like to pass because it's you have this result. I uploaded already the file. Like just to explain it. Now I would like to pass to the determinant and the rank, the trace of a matrix. All these elements are important in a linear algebra. So maybe I can copy this. I would like to copy all this here and take it as a markdown. And I would say that what is important for me is how to calculate the determinant, how to calculate the rank. This is E. Okay. To calculate the determinant, the rank of a matrix. So to calculate the rank, so if you run this, Numpy, linear algebra matrix.
Numpy is NP.
Huh?
Numpy.
Sorry. NP. Okay. Now it's okay. Now its rank equal to 3 because it's a matrix 3 by 3. If it is inversible, it should be like this. Okay. So let's continue. We need also to calculate the inverse of the matrix A. So to calculate the inverse of a matrix A, so إذا B هي الانverse of the matrix A, B would be equal to P dot linear algebra dot inverse of A. So print the inverse. The inverse of A is anti/n B أو B equal anti/n هنا dot format B. I need to add this. Okay, so this is B, which is equal to the inverse of A. If you want to verify this, you can define A, B, a new matrix equal to NP NP dot matrix multiplication of A by B. I'm gonna explain why. This is matricial multiplication. So if you print AB, normally you should find the identity matrix. AB equal to, and here format AB. If I run this, this is my matrix. الماتريكس اللي عندي لو ضربت A في B هلقى هنا واحد، اكيد هي ريال فاليوز يعني فبتلقاها بالفاصل. هنا واحد، هنا واحد، هنا واحد، هنا 10 كود الا 16 ولا 10 كود الا 17. This is the error of the machine. When you have a float, you have a precision of, I think, مو حتى واحد 2.10 exponent minus 60. This is the error of the machine. يعني minus 1, 10 exponent minus 16. This is almost equal to 0. And this value, these values are zeros in reality. Okay? يعني the machine will not count them فعليا. الآن I would like just to say something. If you do C أو equal to A ضارب B هتتحصل على شيء آخر تماما. هنا in this case he will do a dot multiplication. يعني الاليمنت الأول في الاليمنت الأول، الاليمنت الثاني في الاليمنت الثاني etc. لكن إذا تبغى تضرب ماتريكس في ماتريكس لازم تستعمل الفانكشن مات مول اللي هي ماتريسيال ملتبليكيشن. تمام؟ وهذه ممكن نجربها يعني ممكن انا اخذ مثلا ماتريكس سي equal to ones. Maybe I can put it in a ones, for example. Sorry, np dot ones, and you should add a tuple ones 3 by 3. Okay, this is if you print C, you will have this. If you print C, maybe this way, C equal anti/n double bracket format C. If you run it, you will have this value. This is C. I put this just to show you there's a difference between a matricial multiplication and a simple multiplication. So I would use it, and maybe I can take all this here. I will use it just to show you if you do, for example, AC equal to NP dot matricial multiplication A ضارب A كما C هتتحصل على نتيجة. ولو جيت سويت AC1 for example equal to A ضارب C, in this case AC1 I'm going to call it, you will have another result. So if we run this is our result. Okay, maybe I would like to add AC1, AC2 just to make it more visible. AC هنا and here AC1. Okay, let's run it again, and I would like to explain this. So in this one, AC1, when you do A cross C, you do it element by element. Yani our matrix at the beginning, I want to print A. This is A. Print the matrix A. This is the original matrix A. The matrix A is 2 5 17 3 1 4 2 5 1. This is my matrix. لو ضربتها في 1 element by element 2 ضارب 1 هتديك 2 5 في 1 هتديك 5 مش هيتغير ولا شيء. انا اخترت 1 عمدا يعني. لكن لما تبغى تضرب matricial multiplication ايش هتسوي؟ You will take this is my matrix A, you will multiply this line 2 مع 5 مع 17 هتدي لك يعني النتيجة الأولى. بعدين وين AC، بعدين نفس الشيء بالنسبة لهنا نفس الشيء، يعني حتجيك كده حالة خاصة في الماتريكس 1 لما تضرب فيها، لأنك حتاخذ دائما نفس اللاينز تضربها في كالنز متكونة من واحد. فالقيمة الأولى اللاين الأولى حتجيك نفس القيم دائما، اللاين الثاني حتجيك نفس القيم، اللاين الثالثة. بالطبع لو غيرت هذه عوض تكون وانز، هذه ضربتها في 2 حتتغير العملية، حتحصل على شيء ثاني، وهذه ضربتها في 3. ف this is what I would like to show you. Just إنه إيش يعني you should when you want to do a matricial multiplication you should take care about this. In the same logic, I would like to solve this linear system. هنا just I would show you. طبعا linear system ممكن يكون فيه 3 variables، ممكن يكون فيه n variables. When you have a linear system like this, mathematically what we would do? In reality, you should transform this to a matrix. You define the matrix A اللي هي 2 5 0 3 1 4 2 5 1. A ضارب الفيكتور X اللي هو متكون من X1 X2 X3 equal to B اللي هو 2 1 1. لكن B when you define B لازم حتما يكون current vector. This is important, otherwise you will have a false result. فلازم البي تتاكد انه يكون current vector، ما هو line vector، ولا حتتحصل على ماتريكس. احد الحلول انه كل قيمه تحطها في قوس، هذه ملاحظه جيده جدا. الطريقه الثانيه، في طريقه ثانيه انك تسويها كده ايضا، اذا ماتريكس طويله مرات هتقعد تحط كل واحده في قوس، يعني حتكون مزعجه شوي. Okay, let's do this. I'm gonna call this. I can take this same one. I'm gonna take a new one. New console. I'm gonna call it. Okay, I'm gonna call it exercise 2. Class. Okay, so import by as MP. My matrix A. So to solve this linear system, A is equal to. So give me the values. ايش عندنا بالنسبه ل A؟ قلنا A 2 5 0. Another remark, it's important to put the comma. يعني in MATLAB programming if you don't put the comma no problem. In Python لا. In PRA if you don't put it you will have a problem. So okay 2 5 0 and 3 1 4 2 5 1. Okay, I can directly define it here. np dot array, and I put it between 2 comma. So this is my matrix A. I can print A. Okay, this is my matrix. The vector B. الطريقة الأولى اللي I'm registering. Okay. الطريقة الأولى اللي قالها زميلكم هي صحيح. B هي إنه if you want to define, it should be defined as a current vector. So it should be like this. Okay. يعني كل قيمة تنحط في سيل. إحنا قلنا إيش؟ 211. لو حطيت 211 بدون البراكتس هذه، أوكي؟ You will have a problem. Okay. So this is, I'm gonna put np also dot array because it's a list. If you keep it like this, I'm gonna convert it to this way. So I will print b also. This is b, okay? You look to b, this is a current vector. And if you want to solve this system, as we said, you should do my solution x is equal to, you have two ways to do it. The first way, which is I think the worst way, طريقة السيئة, إنك you calculate the inverse of the matrix. This can work when you are dealing with small matrices, يعني matrices 10 by 10, 20 by 20 or something like this. But if the size of the matrix is large, in reality, mathematically, we don't find the inverse of the matrix. We solve the problem indirectly because there is what we call a lower upper decomposition of the matrix A. And this method is used in an algorithm to find X without explicitly finding A. This is the idea. So that's why here we can use NP dot linear algebra dot solve وتحط له A comma B, and you can print your result X. This is X at the end. Okay, it's a current vector. This is your result. Okay, I can write print X equal to X equal to slash n bracket format. Sorry. Okay, this is one way. The second way is to calculate the inverse of the matrix A. يعني إنه you go and you calculate, and this is the worst way. You should not use this method. You should use this one. Find the solution without finding the inverse of the matrix. So inverse of A is np dot linear algebra dot inverse of A. This is the inverse of the matrix A, and you can print it just to see that you have calculated the inverse of the matrix A. So this is inverse of A, وهنا هكتب inverse of A. بالطبع يعني في هذه الحالة, if you calculated the inverse of A, you should do the following. You should go and write that x1 is equal to np dot linear algebra also. No. Matricial multiplication, okay, of the inverse of A by B. Okay, so like this, you will find your result. So in this case, you will write that x1 اللي هو solution of the problem is equal to, so you have the same result, the methods are different. Okay, the second way, imagine you have a long line matrix, for example, and you want to pass it to become to a column. You should reshape this. Okay, يعني أنا مثلا هوريها هنا في مثال صغير آخر. Imagine عندي حاجة زي كده. A equal to A small np dot array واخذ فيكتور مثلا 3 2 5 4 77 إلا 10 12 55. This is a vector. So this is a line vector. And if you want to, this is my A, okay? Print A, sorry, small a. You can also print a dot shape. بالنسبة لي هو this is your A, okay, والشيب تبع A هو 8 elements, okay. الكما هذه لانه بالنسبه لي ما هو معترف انه في كلن وكذا. ف if you want to create a كلن vector فعليا لو حتى استعملت الفانكشن transpose it will not work. This is important. So if you use the function transpose it will not work. Why? Because this is let's say a particular case في Python. If you use it for a matrix, it will work. If you use it for a line or a column vector, it's the same. It will not. You should use the function reshape. Reshape. It means that you change the shape. So you can come, for example, here you define a1 equal to np reshape a. وهنا يا اما تحط n1 number of element length of a او تحط -1 وهذا يعني اخر element عندك 1. We can try both of them. I'm just want to verify it. Print a1 dot shape just to see what is the size of a now. So if you look now بالنسبة لي A1 it's 8 line 1 column. It's different from this one. And if you do it like this, if you print A1, you have a different shape. Look, خلينا احنا نسوي print A بيجي كده. If you print A1, it's like this now. بالطبع you can avoid using this. You can use a length of A. I don't know if the function length or okay, it will work because length of A هو طول ال A و8 فبيدي لك اوكي. لكن في البراكتس تكتب length of A ولا تكتب -1 يعني اخر position of اخر element. ف it's up to you. You can write length of A if it is more suitable for you or like this you define your vector as a column vector. احنا لسه ما خلصنا صح؟ ولا خلصنا؟ اخر شيء ابغى اقوله before finishing انه this is we will use it for plotting. If you are using lists it's a little bit difficult to manipulate long vectors or to define them rapidly, etc. But imagine you are working with an array and you want to define a series of data and you want to plot the function for that series of data. You can, for example, write x, small x. This is equal to, for example, np dot array or np dot a range. A range, this is a function that permits you to define a vector between two values. Yani I can start from 3, for example, to 5 with the time step or with the step h equal to 0, 1. Okay, if I do this, and you run it, I need to plot it, or print x. Okay, so directly you define your series of data because you started from 3 until you reach 5. But طبعا 5 ما يوصلنا لانك انت ياخذ دائما اقل. Okay, so what is good if you are using a library like np array, you can, for example, define y, small y, equal to np, for example, dot sign, the function sign, okay, sign of x. For example, And if you run it, it works directly. It means you don't need to map your matrix or your vector effect. Even if it is a matrix, he will applicate the function sign to all the elements just in one click, which is very very important. يعني لو تسويها بليست هذه you need to do a look for or you need to map. بالطبع you want to plot and to see your figure. So you should import. احنا نظرين الامبورت هذه يحط كله من فوق. You need to import a library. بالطبع دي ما موجودة عندكم. You need to install it. اللايبرري اسمها matplotlib. هذه اسم اللايبرري. يعني انت نظريا هتروح وين؟ هتروح على الكوماند لاين. اوكي، هتحط pip install matplotlib enter. This is اسمها matplotlib. Okay, so انا بالنسبه لي عندي installed. For you, you should install this library. So you can import it as so we're gonna import matplotlib, and inside matplotlib there's a pyplot. Okay, pyplot, and in general the practice as plt, and we will plt dot plot xy, and you can add options for this. Okay, you run it, you have your curve. Certainly if you come back here and you define, for example the sign, the range here from 0 to let's say to 20, and you run this again, maybe I don't need to print it, and you run this again, calculate the sign, and you plot the curve. This is your curve. Certainly this curve you need to add axis, x label, y label, title. You can add all this. So you can add here plt dot x label. So, and you write that the x axis, maybe it is a time in second or something like this. And here you have plt dot y label. And I'm gonna write sign of x. I can add a title, plt dot title, title. Okay, so this is my title. This is my first graphic. Okay, so if you run this again, you obtain this kind of result. Okay, this is lt dot save figure. I can save the figure and I will call it figure 1. Okay, so if you run it .png, for example, if you run this and you go to your assignment, normally you find this image. No, not this one, this one. Find this figure and you can insert it and use it in your office by going and inserting. Okay, so this is your figure and you insert it and you adjust it as you want. So this is mainly the idea here. Okay.